Hi, this is Ms. Hood, and this week we're going to talk about functions. So what is a function? Well, in junior high, they explain that a function is something that takes an input and gives you an output. So let's look at an example of something that might be a function. I have something I call a circle machine. So I take a shape, whatever shape I put in, it gives me a circle. So if I put in a green rectangle, my output is a green circle. If I put in a yellow pentagon, my output is a yellow circle. A purple triangle gives me a purple circle. A purple octagon gives me a purple circle. Hopefully, y'all are seeing how this works. What if I use a blue circle as my input? Am I allowed to do that? Yeah. I get the same blue circle as an output, right? Didn't do anything, but that's okay. I'm allowed to put circles in there too. What if we have a box that looks like this instead? Y is equal to 4 times x. Which one is the input, the x or the y? Well, anytime we have an equation like this, the input is always the x, the output is always the y. So if I use 2 as my input, I put that in for x. I have 4 times 2 is 8. Y is equal to 8. That's my output. If I use -3 as my input, my output is -12. I could put in a fraction. If my input is 1/4, 4 times 1/4 is 1. That's my output. So if I have only the output, and I know if I'm what equation I'm using, can I figure out the input? Yeah, I can. If I tell you I got an output of 8, and you know the equation is y is equal to 4x, you know y is equal to 8, you can figure out x is equal to 2. If I tell you the output is -12, you can figure out the input was -3. I divide by 4. If I tell you the output's 1, the input was 1/4. So what about the circle machine? There's my output from the circle machine. Now you might remember, right, I put in a green rectangle to get the green circle, but could I put in a green star and still get a green circle? Yeah, I could. And what about the purple circle? Did that come from an octagon, from a triangle? I have no way of knowing. Right, so those two examples that I gave you are not really exactly the same. Let's talk about a couple of definitions. This idea that I'm talking about, this function, sometimes instead of a function, we call it a relation. So this is what we need to talk about next. A relation is a collection of ordered pairs. So you've got object X from one set as your input, object Y from another set as your output. So the example of my circle machine, right? I have my input, the green rectangle, along with the output, the green circle. I have a blue circle from X as the input, a blue circle Y as the output. Right? Everything is in pairs. That's called a relation. A function is a special kind of relation that assigns each x value to exactly one y value. So every input has a very unique output. So is my circle machine a relation? Yes, yes it is. Every input has an output. They're in pairs. That's a relation. Is it a function? Does every input to my circle machine give me something unique? And now the answer is no, right? I get out a circle no matter what shape I put in there. So it is not a function. I can't look at my output and figure out what input it comes from because it's not unique. That output is not unique to the input. So what about my equation y is equal to 4x? Is that a relation? Yes. Yes, it is. Because for every x, I've got a y. For every input, I have an output. They come in those pairs, those xy pairs. Is it a function? It turns out, yes, it is a function. Every input gives me a specific, unique output. And I can look at that output and figure out what the input was. That's a sign that it's a function.